Good morning. This video is going to cover questions 11 through 17 in the final exam review packet. This will finish up all the Unit 5 questions, which are statistics and probability. So number 11 says, Jack and Jill surveyed students in their school to estimate how many students listen to classical music. Jack's sample was to survey 50 orchestra students. Jill's sample was chosen by selecting students randomly from a list of all students in the school. Will Jack or Jill's sample be more likely to be representative of the school's population? Use mathematics to justify your answer. So this kind of goes back to the whole simple random sample concept that we talked about. And remember, a simple random sample is a sample where everyone has an equal chance of getting selected. Okay, and there's no bias. So we're looking to see which one of these samples, or which one of these surveys, which one of these samples is more likely to be representative of the school's population, or is a simple random sample. Jill's sample is by far more likely to be representative of the school's population. Jack's sample is biased because he's just surveying orchestra students, and you're trying to get a survey of the entire school. So Jill's sample is more representative. As I said, all students have a equal chance of getting selected. Okay, number 12, the table below shows the results of Jill's survey from item 11. You have a little chart, and it says, first bullet says, based on the results of the survey, if a student is chosen at random, what is the probability that a student listens to classical music? Explain how you determined your answer. Use words, symbols, or both in your explanation. Okay, so there are 50 students in total who are surveyed. I'm trying to find the probability that a student listens to classical music. Okay, so the chart says number of students listening to classical music is 10, so our probability is 10 over 50. I like to simplify, so probability can be expressed as a fraction, a decimal, or a percent. Now again, reminder, if it is a grid and percent is not going to work, you're going to just need to do a decimal or a fraction. Okay? But all three of those are acceptable answers in a BCR format. Second bullet, based on the results of the survey, if there are 800 students in her school, predict how many students listen to classical music. Explain how you determine your answer. Use words, symbols, or both in your explanation. So again, we're just going to show our work, and in this case, we're going to set up a proportion. So we have 10 over 50. 10 students, number of students listen to classical music out of the 50 who were surveyed, okay, equals x over 800. And we're going to solve this proportion. Just to remind you, when you solve proportion, you cross multiply. So that's going to be 50 times x. So we have 50 times x equals 10 times 800. 50x is going to equal 8,000. Divide both sides by 50. Unless my math is incorrect, we are going to get 160 as our answer. So that'd be 160 students listening to classical music. Okay, 13. Hairless and Seattle Inc. is marketing its hair growth cream. The two graphs below are being considered for use in magazine ads. The two graphs represent the same information. Why do the two graphs look different? So you really need to focus on graph 2. Okay, graph 2 has a y-axis. Look at the y-axis. It starts at 1 and not 0. Okay, so that allows the person who created this graph to make it a misleading graph and makes it look like that there's a lot more growth in the hair length than there actually is because of it. So graph 2 has a different y-axis Okay, and it starts at 1 rather than 0, and it needs to start at 0 to be an accurate graph. So graph 2 is a misleading graph. Number 14, on the first 5 weeks of a job, Nancy earned $50, $50, $80, $90, and $300. Which measure central tendency is best representative of Nancy's weekly income? Explain your answer. Okay, if I wanted to, I could go through and find the mean, median, and mode of this. In fact, I can do that real quick. So mean's going to be, I'm just going to add them together. And divide by 5. So 400. I believe that would be $570 divided by 5, which, if I'm not mistaken, would be about $114. So that would be the mean. The median, I can quickly do by hand because I just put them in order from least to greatest. The middle number would be the mean, which would be 80. I'm sorry, the middle number would be the median, which is 80. And then the mode is the one that occurs the most often, which in this case is 50. So which one would I use? Which one is the best representative of Nancy's weekly income? In this case, it's going to be the median. We're going to use the median because there's an outlier or a piece of data that does not go with the rest of the data. Okay? If you look at that $300, it is nowhere near the other 4 pieces of data. So that is something, it doesn't belong with the data, or it doesn't fit with the rest of the data. So when you have a piece of information like that, use the median so that that one piece of data doesn't bring the value way up or way down. Okay, because when you have a really high outlier like that, the mean is going to be drawn much higher. So $80 is a much better representative of the weekly income rather than $114. Okay. 15. Nathan is conducting a simulation concerning seniors who ride a bus to school. It uses a random number table with digits 0 through 9, where 0s, 1, 2, and 3 represents a senior who rides a bus to school, and 4, 5, 6, 7, 8, 9 represent seniors who do not ride a bus to school. Based on the digit assignment, what is the probability that a senior rides a bus to school? So with 0 to 9, we have 10 digits. And it says 1, 0, 1, 2, and 3. So that means that's 4 there represents ride to school out of 10 total. So 4 out of 10 represents 40%. So that's going to give us C as our answer. Okay. (16) Describe a model you could use to simulate a probability that 25% of all students go to the movie each week. Okay, so we did a little bit of this back in February where we were designing simulations, and you just kind of have to figure out how 25% is as a fraction. That might help you. So 25% can be written as a fraction as 1/4. So I'm going to give you 2 possible scenarios you could use. The first scenario would be a 4-section spinner. Okay, where 1 represents they go to the movies, and then 2, 3, or 4 do not go to the movies. Okay, one other way you could do it would be a 6-sided number cube. Now this one's a little different. 6-sided number cube or a 6-sided dice. Okay, where again you would say 1 goes to the movies. You would say 2, 3, 4 does not. And then this is a little bit different. You would actually just ignore any rolls of 5 or 6 and re-roll. But you could do it that way as well and it would still work. So those are 2 possible models you could use to simulate a probability of 25%. Okay, the last question I'm going to go over in this video, 17. Mr. Van Dorn states that there's a 30% chance that a student is tardy to his class. Which of the following models can be used to simulate probability? Now before I go on, I'm going to rewrite 30% as a fraction as 3 out of 10. So I'm looking for any model that gives me a chance of 3 out of 10. So as I go through each one, I'm going to put down fractions, and it has to match up to 3 out of 10 for it to be something I could use. So we look at A random number table is digits 0 through 9, where 0 is 1, 2, 3, 4, 5, and 6 represent a student that is tardy, and 7, 8, 9 represent a student who is not tardy. So we're trying to find the probability a student is tardy, so this one would actually be 7 out of 10 because there's 7 numbers here. Okay? And the 7, 8, 9 represent not tardy, so that's how it's 7 out of 10, so it would not be A. B, a random number table digits 0 through 9, where 0 is 1, 2, 3, 4, and 5 represent a student that is tardy, and 6, 7, 8, 9 represent a student who is not tardy. So again, that would be 6 out of 10. We're again looking for 30% or 3 out of 10, so B is not going to work either. C, a random number table digits 0 through 9, where 7, 8, 9 represent a student that is tardy, and 0, 1, 2, 3, 4, 5, and 6 represent a student who is not tardy. There are 3 numbers here that represent a student that is tardy, so that would be 3 out of 10. So C is a correct answer. Let's check D now. A 6-sided die where 3 represents a student that is tardy, so that would be 1 out of 6. Again, that would not be useful, so C is the only correct answer in this problem. Again, at this point, if you still have questions on these problems, you need to come see me at lunch or after school for help.